Okay, today's notes are over inverse functions. An inverse function is written like this, f to the negative 1. An inverse is basically, the inverse of a function is the function's reflection over the line y equals x, which is set over here. In order to find the inverse of a function, you're going to have to replace y with f of x, then switch x and y and solve for y, then replace y with f to the negative 1 of x. So let's go ahead and start in number 1. Remember, the first thing we need to do is instead of f of x, we write y. Now we need to switch x and y. So x is equal to 10y. Now we solve for y. We need to get y by itself. Divide both sides by 10. Now we get y is equal to x over 10. Remember, the last step says to replace y with f to the negative 1 of x, which means inverse. So this is the inverse of the function. Let's go ahead and graph this. The first thing I want you to do is draw this diagonal, which is the line which is going to be the line of reflection between the function and its inverse. Next, I want you to draw the function. In order to do that, you need to make a table with random values of x and y. I'm going to pick negative 1. If x was negative 1 and you plugged it into this function, y would be 10. If x was 0, then y would be 0. If x was 1, then y would be 10. Go ahead and plot those points and then draw. Make sure you label. Now go ahead and do the same thing for the inverse function, the inverse of the function. So go ahead and make a table. Pick random values of x and y, and then plot those points and draw your... Here's a table with the points I used, and in the red you can see the inverse function. As you can see, f of x and the inverse are reflections of each other over the y equals x line. Let's go ahead and move on to number 2. First thing you need to do is make f of x y. Now we replace x with y and y with x, so switch the x's and the y's. Now we solve for y, so plus 7 on both sides. Then we can either divide by negative 1/5 or multiply by negative 5. I'm going to multiply by negative 5. Okay, so on this side, the negative 1/5 and the 5 are going to cancel out. And on this side, we're going to distribute this negative 5. So we have negative 5x minus negative 5 times 7 is negative 35. The last step is to replace y with f to the negative 1 of x. Go ahead and draw f of x and its inverse. First, draw that line of reflection. Now draw f of x, then f of negative 1x. There goes the line of reflection, f of x, and its inverse. Now I want you to go ahead and try number 3 on your own. So go ahead and pause this video, work on it, and then press play. Okay, now I'm going to move on to number 4. In 5, it says determine whether each pair of functions f and g are inverses. Explain your reasoning. In order to tell that they are inverses, all these x values have to be the exact same as the y values of the other function, and all the y values of the original have to be the exact same as the x values of the other function. So let's go ahead and go one by one, checking to see if we have the exact same. Things switch. So starting off, we have -4, -4, -4, -3, -3, -2, -2, -1, -1, 0, 0, 1, 1. So the x exactly matches the y values here. Now we need to check to see if these y values exactly match these x values. Here they look the same, 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 same. So the answer would be yes, they are inverses of each other because the x and the y coordinates are switched. Now I need you to go ahead and try number 5 on your own to see, do the exact same thing we did for number 4. If you need to rewind, go ahead and rewind it. Now you need to make a note, well, it's already up here. It says the inverse of a function is not always a function. Here is an example of a function. F of x is equal to x squared, which is a function, but its inverse, which is this, is not a function. I can tell you in class why that is. I think if I tell you here, you're just going to get confused. So let's skip that for now. But we need to make sure that you know that when the domain of the original function is restricted to only non-negative real numbers, the inverse of f is a function. So if we want the inverse of this function to be a function, we just have to use the non-negative values. So that would be just this right here. Okay, let's go ahead and move on. Number 6, we need to find the inverse of the function, then graph the function and its inverse. So here, as you can see, the domain is restricted. Every time you have an x squared, make sure you restrict the domain, because if not, then remember, if we don't restrict the domain, then the inverse is not going to be a real function, and we want both of them to be real functions. So let's go ahead and start. So it's what we've been doing. First, you replace f of x with y. Now we switch the x and the y. Now we solve for y, so get y by itself. In order to get rid of that squared, we need to square root both sides. And remember, when we have a even index, so this is an imaginary 2 right there, we have a plus and minus. But if you remember here, we are only using non-negative numbers. So we can get rid of that negative. Oh, just a negative. So y is equal to the positive values of square root of x. Now we replace the y with f to the negative 1 x. And we're going to go ahead and graph those. Okay, so this is the graph of the line of reflection, f of x, and its inverse. Okay, now let's move on to number 7. So first thing we need to do is replace f of x with y. Now we switch the x and the y. Now we need to get y by itself. So we need to get rid of this square root. The opposite of square root is square. So square both sides. X squared is equal to y plus 2. Now minus 2 on both sides. We said minus 2. Okay. Now last step is to replace y with f of negative 1, x. And remember I told you if we have an x squared, we need to make sure to restrict its domain. Restricting its domain is just saying x is greater than or equal to 0 to make sure that we only use non-negative x values so that both our function and our function's inverse are functions. Okay, so now let's go ahead and graph. And here is our function and our inverse and our line of symmetry, right? Okay, so I want you to go ahead and try number 8 on your own. So do the same thing we did above. Make sure to restrict the domain if you need to. Okay, now let's move on to the bottom. It says, or I guess yours is the second page. Anyways, now we're going to learn about using the horizontal line test. It says the inverse of a function is also a function if and only if no horizontal line intersects the graph of f more than once. So in order to tell if the inverse of a function is going to be considered a function, then the horizontal line can only touch the function once. If it touches more than once, then the inverse is not going to be a function. So here you can see we've only touched that horizontal line once, so that means the inverse will be a function. On the next graph, we touch that horizontal line 2 times. So that means that the inverse is not going to be a function. Okay, now move on to number 9. We need to use the horizontal line test to determine whether the inverse of this function is going to be a function. So if we draw a line, horizontal line here, we can tell that it touches 2 times. So no, the inverse is not going to be a function because this function does not pass the horizontal line test. I want you to try and do number 10 on your own. Remember, all you have to do is draw horizontal line and determine whether the inverse is going to be a function or not. So remember, if it touches once, it is a function. If it touches more than once, then it's not going to be a function. Let's move on to number 11. It says consider the function, determine whether the inverse of f is going to be a function, then find the inverse. So I want to go ahead and graph this function, and then we can use the horizontal line test to determine whether or not the inverse is going to be a function. So here's our function, and if we draw that horizontal line, we can see that it only touches once. So the function, the inverse of this function is going to be a function. Let's go ahead and solve for the inverse. So first off, replace f of x with y. Now you switch the x and the y. Next step is to solve for y, so you need to get y by itself. I divided both sides by 2. Now I need to get rid of that square root, so I need to square both sides. Next, I need to add 3 to both sides. Last step is to replace y with f to the negative 1. Remember to restrict the domain since we have x squared. And now go ahead and graph. And that's it. We're done.